In this random science episode, we are going to explain to you about digital twins that are a virtual replica of everything that exists in the real world. Visualize living in a future where every car or plane, every patient, every building, or even entire towns has its own virtual, real-time electronic replica or digital twin, which is constantly updated. The digital twin is a notion that has gained popularity recently, and it has the potential to improve our lives by measuring, analyzing, repairing, and improving them in the actual world. It is possible that the phrase, "if in doubt, clone it," will become the credo for the future generation of engineers, construction managers, and surgeons. Digital twins gather information from internet-connected items through the use of sensors, software, and control systems, i.e., Internet of Things devices, and use it for more than merely simulation. They collect and analyze information such as temperature, position, air quality, and speed in order to adjust and improve design or function. This is nothing new when it comes to real-world items such as bridges, skyscrapers, and other huge construction projects. Engineers have been gathering this information for decades through the use of sensors and other devices. However, as the cost of Internet of Things devices connected to the Internet continues to plummet, digital twins can use data nearly instantly to see the consequences of changing conditions and make adjustments as quickly as possible. In the construction industry, this means that buildings will be safer and more affordable to construct since digital twins will have access to real-time weather, structural, and stress point information. Water level and wind speed threshold data are used on bridges such as the Queen's Ferry crossing in Scotland, for example, to improve safety and traffic flow while maintaining traffic flow. Building systems such as heating, lighting, and ventilation may all be automated and monitored from a distance. Smart cities are created as a result of connected buildings, in which buildings communicate with one another and future performance may be forecasted. A digital twin of the entire state of Victoria, Australia, is being constructed by local government officials with the goal of transforming urban planning and infrastructure construction. The United Kingdom is developing a strategy to connect buildings and digital twins across the country. The manufacturing industry is another industry that is being impacted by digital twin technology. Using thousands of sensors across the manufacturing line, firms may gain insight into how work is performed at each step of the process, the efficiency of the system, and any bottlenecks that may exist. However, it also enables for the testing of other situations, such as how raw material shortages or price fluctuations may affect the company's operations. Every Boeing aircraft, system, and individual airplane part is created as a virtual replica, exact functional versions of each complicated system and individual component for testing purposes. Its whole engineering and development system has been digitized, allowing engineers to retrieve the current state of any asset at a moment's notice. Boeing was able to reduce costs and development time on its 777X twin-engine jet by as much as 50% as a result of quality improvements resulting from twinning on its air data equipment. This idea of maintaining a persistent set of computational models that are constantly being updated and evolved alongside a physical asset over the course of its entire life cycle, according to researcher Michael Kaptein, is at the heart of digital twins. He is investigating how scaling up digital twin computer models might handle a whole fleet of aerial drones. The fixed-wing unmanned aerial vehicle employed by the study team was equipped with sensors and was used to verify instrument calibration as well as simulated flight damage. Once the damage had been assessed, the UIV's digital twin predicted how the flight would be affected and recommended improvements to ensure that it could continue safely. Final goal is to enhance the technology's capabilities to handle various issues, such as airplane fleets, wind farm turbines, or even heart patients. Furthermore, wind turbines are already benefiting from predictive data derived from digital twins. A new foundation steel jacket for offshore wind turbines has been developed as a result of an EU-sponsored design initiative, which decreases costs by 30%. Another digital twin effort in the energy business, this one in Australia, assisted in modeling the danger of wildfires caused by vegetation touching electricity lines. The use of aerial LiDAR and imagery data, combined with machine learning, has the potential to reduce the amount of money spent by energy firms on vegetation trimming by up to 40%. When electrical networks are transformed into smart grids via the use of advanced software and smart meter feedback, digital twins created by energy companies can model for renewable energy inputs and storage batteries, and then we'll be one step closer to smart cities and responsive buildings that reduce their influence on the environment. The digital twin concept is also used in healthcare, where it can be used to create computer models of sickness or even a virtual human body. A medical twin of each patient might therefore be used to generate personalized medicines or therapies for that patient, filling in the blanks for particular organs utilizing body data-linked computer models, such as Philips Virtual Heart or the Blue Brain Project, is only the beginning of what is possible. Health trackers collect whole person data, including heart rate, blood pressure, breathing, and other vital signs, and then provide recommendations on how to improve our lifestyle. This could prevent health problems from arising in the first place by identifying risk factors and intervening before they manifest themselves.